Today I'm going to go over a basic hypothesis test. So what a hypothesis test is a test used to determine whether there is enough evidence in a sample of data to infer that a certain condition is true for the entire population. So basically, to give an example, say a friend told you that the average weight of a pizza, of any pizza that comes out of your local Domino's, was 4 pounds. But we don't believe him. He's a shady guy, and we're pretty sure that it's more. But we want to test this just to be sure. So in this example, the null hypothesis, or what we assume, is that the mean pizza weight is 4 pounds, while the alternate, or the alternative hypothesis, is that the mean pizza weight is more than 4 pounds. We can't go around and measure everyone's pizza as it leaves the store, so what we do is we get a sample. We order 1 or 2 or 3 pizzas, and we average all of their weights, and we get a sample mean for the weight of the pizzas. So the average we get is our observed value of the mean, our sample mean. So in this example, the distribution of the weights of all the pizzas follows a normal distribution right here. And it's a bell curve, and it looks like this, where the x-axis is the weight of the pizzas, and the y-axis is the probability that any of these weights would show up if you ordered a pizza. Say we got a sample mean of 4.1 pounds. We got a sample mean of 4.1 pounds. The concept of the hypothesis test is that given the null hypothesis, or the fact that we're told the average pizza weight is 4 pounds, what's the probability that we observe a value greater than what we observed? In this case, what's the probability that a sample of 3 pizzas we order have an average weight of 4.1 pounds? Now, given this distribution, with our assumed mean of 4 pounds, the distribution centered around the assumed null hypothesized mean, we can see that our observed value right here, we can see that our observed value would lie right here. And as we can see, the probability of this happening, or the probability that we would observe a value greater than this, would be 0.4. And we can agree that this is a really likely observation, given that the assumed average is 4 pounds. So for this test, we say that we fail to reject the null hypothesis and assume that the average is 4 pounds. Now say we do a second test, a second hypothesis test, and this time we order 3 pizzas, we average them out, and we get a sample mean, the sample average of 5 pounds. We can see here that given the null hypothesis that the average weight is actually 4 pounds, that the observation is highly improbable. It's all the way over here, in that the probability of this happening is 0.005. Now we say that we reject the null hypothesis, and we can agree that the actual mean weight of pizzas put out by Domino's has to be higher than 4 pounds.